Okay, this is College Algebra, Unit 1. Unit 1 is talking about equations and inequalities. Lesson 1.1 talks about linear equations. So there's a difference between equations and expressions. Now remember, anytime on any of the videos, if you need to pause the video to catch up on the notes, or maybe watch the video at a faster rate, you can do that based on what you need. Make sure you're listening to the video, because there's a lot of stuff that I say that maybe I don't write also. Okay, so on equations versus expressions. On equations, there's going to be an equal sign. You can solve. Expressions, you can reduce. When you solve, another name for solution is a root, or the plural of that would be roots with an S. Okay, so linear equations are equations that are first degree equations. That means that the highest exponent is 1. Okay, so we have some examples here. 3x plus 2 equals 5. You can see the highest exponent on x is 1. The 2 does not have a variable, therefore you could say that that's x to the 0 power. And you can see that the highest exponent is 1, so it's a first degree equation. It is a linear equation. The second example, 4.2 plus 5 times the parenthesis x minus 3 parenthesis equals 8. As you can see, there's one variable. The exponent on that variable is 1. Some non-examples. Okay, square root of x equals 9. If you remember back from Algebra 2, square root, another notation for the square root of x would be x to the 1/2 power. So x to the 1/2 power is not a first degree, so it's not a linear equation. 1 divided by x equals 3. The variables being in the denominator make that it's not a linear equation. Also, you could say that that would be x to the negative 1 power equals 13, which again is not a first degree equation. And then finally, x squared plus 7x minus 8, x squared to the second degree. If it has a degree 2, then 1 is not the greatest. Another example, we could have 3x plus the square root of 2 equals 0. It's okay to have the square root of 2, as that's not an x that you're taking the square root of. Technically speaking, I guess you could have had the square root of 3 times x plus the square root of 2 equals 0, and that would still be linear. Then we have 3/4 x plus 12 equals 9. The x, when it is right beside the fraction like that, actually can go in the numerator, because if that's multiplication, 3/4 times x, that's 3/4 times x over 1. And so the x is in the numerator, has a degree of 1. So those are some examples, some non-examples. All right, when we solve equations, we remember to use the addition property of equality and multiplication property of equality. The main idea of addition property of equality and multiplication property of equality is what we do to one side of the equation, we must do to the other side of the equation. So if we multiply one side by 2, we have to multiply the entire other side by 2. Most mistakes that I see made here are when you don't do it to everything on a side. You only do it to one of the terms on the side, not to all terms. So be careful. Make sure you're doing it to all terms. Okay, so we have some examples. We're going to solve 3 times the parentheses of 2x minus 4 equals 7 minus x plus 5. The 3 needs to be distributed to the first set of parentheses. In front of the second set of parentheses is a minus sign or a negative sign, and we will distribute that to the second set of parentheses. Okay, so we get 6x minus 12 equals 7 minus x minus 5. Okay, now we're going to combine like terms on each side. Then we can start doing the addition property of equality, which means if I add an x to one side, I have to add it to the other. If I add a 12 to one side, I have to add it to the other. This reduces, so we get 7x equal 14. Then we can do division property of equality. We get x equal 2. Note to yourself, remember, always check your work. Make sure that it's a reasonable answer. Is 2 a reasonable answer? So could we take 2 and plug it back in for x to solve? And yes, it does work. Is 2 even an answer that would make sense? That's kind of a good way to check yourself. Okay. Another example, we have 2x plus 4 over 3 plus 1 over 2x equal 1 over 4x minus 7 over x, or 7 over 3. Doing problems like this, we have fractions. A lot of people don't necessarily like to work with fractions. If you wanted to split it up so that everything was its own fraction, like 2x over 3 plus 4 over 3 plus 1x over 2 equal 1x over 4 minus 7 over 3, you could. But a lot of times it's easier to multiply through by a common denominator. So for 1/3, 1/4, 1/2, common denominator is 1/12. We multiply everything by 12, everything on both sides. Notice when we take the 12 times the 3 that's in the denominator, so 12 with the denominator of 3 reduces to 4. 12 with the denominator of 6 reduces, 12 with the denominator of 2 reduces to 6. 12 with the denominator of 4 reduces to 3. 12 with the denominator of 3 reduces to 4. So that's where those numbers come from, the 4, the 6, the 3, and the negative 4. And now we're just solving like we did on the last problem. Distribute, combine like terms, use addition and multiplication properties of equality as needed. A thought there about decimals. If a problem has decimals, multiply through by a power of 10 to eliminate the decimals, and then that might make it easier to work on. Okay, when we solve linear equations, or when we have linear equations, there's 3 main types. The first type is called conditional. That means one number or some numbers work and some numbers don't. It's conditional based on what the number is. So, for example, the last problem that we did, we had x equal negative 4, I think it was. So when x is negative 4, it works. When x is not negative 4, it doesn't work. So it's conditional. The next type of equation is called an identity. When you're solving identities, you get x equal x or 5 equal 5. You get something that's always true. 0 equals 0 even. Then there's a contradiction. 5 equals negative 3. That's not going to work. An example that I've given you here is 3 times the parentheses 3x minus 1 equals 9x plus 7. We can take on the left-hand side of the equals and distribute the 3. Now we can start solving that, subtract 9x from both sides. We get negative 3 equals 7. That's not true. That's a contradiction. These are the equations that are going to be no solution. So we have conditional, identity, and contradiction, just being able to identify those. So last topic here, solving for a given variable. So if we have an equation, I equal p times r times t, solving that for the variable p, since p is both multiplied by r and t, and we need to get p all by itself, we can simply divide both sides by r and t. So I divided by rt equals p. Kind of basic, not too bad. Undo what's being done to the variable that you need to solve for. Undo what's being done to the variable that you need to solve for. Last example here, a minus p equals p times r times t. If we solve that for capital P, since p is already on both sides, you must get it on one side. So add the p over. Factor out a p. So both prt plus p had a p. So if I factor that out, it's the opposite of multiplying it. So that's how come inside the parentheses we need a 1. And we divide by the RT plus P. Oh, I guess I have another example. Solve for capital B. So we had to multiply the 2 to get rid of the 1/2. Then we had to divide the h to get rid of the h. And then we could subtract the lowercase b. there's your notes for lesson 1.1.